Here's pre-calc. It's the closure problem 6-143. So it's asking us, use the following vectors to complete part A through C. And you'll notice all the vectors, they're all in different kinds of, like some are in component form and some of them are in I and J. Letter A says, which pair of vectors have the same direction but not the same magnitude? So the same direction but not the same length. Because remember, vectors are just little, they look like little arrows, right? And they have like, they have a length, which is the magnitude, and then they have a direction. So I went ahead, because you can't really tell when they're all in different, like I want them all to be in component form so I can compare them more easily. So I just went through and put the ones that weren't, like this one's in component form. I put this one in component form. This one now, since it didn't have an I component, it's 0, 3 root 2. And this one's 0, 4. So even though the answer book doesn't say it, I feel like these two are actually in the same direction because they're going right 0 and up. Like this one goes right 0 up 4. It probably looks like this, the length of 4. And this goes right 0 up 3 root 2. Well, 3 root 2, I don't know what 3 root 2 equals, but it's probably equals more than 4, but it's not equal to 4, so it has a different magnitude. 3 root 2, anyway. I should know this because it's a popular number. It's about 4.24. So these two, but your answer key is saying it's these two vectors. And I actually, the first time I did the problem, I didn't notice these two vectors. I noticed these two. Because this one, 3, if it goes, let's say that we multiply, like we rid ourselves of the fractions or whatever, and then we'd have 3 comma negative 4. And then if we multiply them both by 3, so basically if we multiply them both by, what would it be, 15? Anyway, if I multiply them both by 5, I get 3 negative 4, and then if I multiply them both by 3, I get 9 negative 12. So I guess if I multiplied them both by 15, like if I scaled them up by 15, then I would have the same exact vector as this one. And so, and I noticed your answer key says something about slope, and that's because like this one right here, it goes right by 9, and it actually goes down by 12, and so it's gonna look like this dark arrow that I'm drawing right here. This one goes right by 3/5, which is pretty small, right by 3/5, and down by 4/5. So it's a little tiny vector, but you can see that it has the same slope. It goes the same direction as this bigger one. So the answer to letter A is vector V and vector VI. They have the same direction, but a different magnitude. I think it could be argued that triple I and like the 3 and the 4, I think you could argue that they also have the same direction because they both go straight up and they have different magnitudes. So I'm not sure why that wasn't listed in the answer key, but here's the official answer. And then letter B says, which pair of vectors has the same magnitude but not the same direction? So then I was thinking, oh, I guess I need to get all, like these two have the same direction, but this one has a much smaller magnitude than this one. So now I'm looking for ones that have the same magnitude but a different direction. So I just went through and found the magnitude of everything. So like the magnitude of this one would be, remember it's the length, and you use Pythagorean theorem. So it's 9 squared plus 12 squared equals c squared. So So better get out our calculators. 225, of course. I think it's going to be 15, right? Square root answer, yes. So the magnitude is 15. I'm just going to write the magnitude real small on these. This one's magnitude is going to end up, I think, being 1, because I think this one's our unit vector. So let's see, 3/5 squared plus -4/5. When I square it, it'll be positive again. Equals c squared. So that's, let's do it down here. Well, 9 plus 16 is 25. So 25/25 is 1. So then the square root of 1 is 1. So this one's magnitude, I don't know a symbol for magnitude. I'm just going to go, like, I know that we can go like this. Something I can do some kind of magnitude notation. I'm just going to use m if you don't mind. It's not the slope, it's the magnitude. So this one's magnitude is 1. I don't know. This one has a magnitude of 4 because it's just going straight up by 4. This one has a magnitude of 3√2. It's just going up straight 3√2. This one would be 1 squared plus 2 squared equals c squared. So 1 plus 4, that's going to be √5. That's a magnitude. And then this would be 3 times 3. This is √18, I think. Okay, so who has the same magnitude and a different direction? Wait, this one. Because isn't 18 the same as 3√2? Let's see. 18 is 9 times 2. This is 3√2. So it's these two. It's I and, you couldn't see that whole time. It's I and triple I. Those have the same magnitude because when you do that Pythagorean theorem and find the magnitude, they both have 3√2. This one I didn't have to use Pythagorean theorem because I knew it was just a vector that goes straight up. So I and triple I. And then letter C, which of these is a unit vector? Well, when I did the Pythagorean theorem on this one, and remember I did all this work down here, I found out that its length was 1. This magnitude is 1. So that means it's a unit vector. That's the definition of a unit vector, is that its length is 1 unit. So I'm going to say it V.